You know, all around us, there's this invisible army of machines just powering our world. They're the quiet, tireless hearts of industry, doing all the moving, lifting, and making that we totally depend on. But what happens when those hearts start to get sick? Well, today, we're going to give these machines a much-needed health checkup.
All right, so here's our game plan. First, we're going to listen in on the industrial heartbeat and meet our patient. Then, we'll dive into what happens when good gears go bad. After that, we'll crack open the machine doctor's toolkit to see how we actually monitor their health. And to finish up, we'll take a peek into the incredible future of machine health. Ready? Let's get into it. So for this whole explainer, we're going to focus on one of the most critical yet overlooked components in all of engineering, the industrial gearbox. Seriously, you can think of it as the powerful, unsung hero working away behind the scenes.
Now, this thing is a total marvel of engineering. Its job sounds simple, but it is absolutely vital. It takes all that high-speed power from a motor, and get this, it transforms it into low-speed, high-torque force. So what does that mean? Basically, it trades speed for pure, raw strength. That's how a relatively small motor can move something absolutely massive. So where do you actually find these powerhouses? Honestly, the better question is, where don't you find them? I mean, they're everywhere. They're spinning the gigantic blades of wind turbines, they're pulling elevators up skyscrapers, they're running the conveyor belts in pretty much every factory, and they're digging deep in mining equipment. And here's the really crucial point. If just one of these fails, it can bring an entire operation to a grinding and very, very expensive halt. And that brings us to the big problem, right? These machines are under incredible stress, day in and day out. And just like any system that works that hard, they can break down. So what does it actually look like when these industrial hearts start to fail?
You know, the key thing to get about failure is that it's not always some big, catastrophic explosion of metal parts. This quote really nails it. Failure starts the second a gear just can't do its job efficiently anymore. It's a slow decline in health that, if you don't catch it, well, that's when you get those much bigger problems.
And wow, when you see the contrast, the stakes just couldn't be clearer. I mean, look at this. On the left, you've got a healthy, perfect set of gears, doing exactly what they're supposed to. On the right, that's the devastating result of a failure that was left unchecked. That is what happens when those early warning signs of sickness get ignored. The difference is just night and day. So just like a doctor learns to diagnose different illnesses, engineers have identified specific diseases that affect gears. These are what we call the common modes of failure. And each one has its own cause and its own symptoms that we can spot long before we get to that catastrophic endpoint.
Let's start with a really common one, pitting. The best way to think about it is like metal fatigue. Under all that repeated high stress, these tiny little cracks start to form on the surface of the gear teeth. And eventually, little pieces of material just flake off, leaving these pits. It's one of the first and clearest warning signs that the surface is wearing out.
Okay, now this one is way more severe. Scoring, this happens when the lubrication, which is literally the lifeblood of the gearbox, breaks down. Without that thin, protective film of oil, you get metal grinding directly on metal. And the friction creates so much heat that the surfaces actually weld together for a split second, only to be ripped apart as the gears keep turning. Yeah, it is just as brutal as it sounds.
And then you've got wear. This is more of a slow, chronic illness for a gear. It's just the gradual removal of material over thousands and thousands of cycles. But this process can get sped up big time if contaminants like dirt or little bits of metal dust get into the oil. When that happens, you've basically turned the helpful lubricant into liquid sandpaper.
So we've seen the diseases, and it all sounds pretty grim, right? Well, the good news is engineers have developed this incredibly sophisticated toolkit to diagnose these problems early. And it's all built on one core idea, actually listening to what the machine is trying to tell us. This whole practice has a name. It's called condition monitoring. And it's really the engineering version of preventative medicine. So instead of waiting around for a machine to break, you're constantly checking its vital signs to catch problems before they become catastrophes. It's a massive shift from just reacting to failures to actually getting way out ahead of them. And in the Machine Doctor's Toolkit, there are two primary diagnostic tools that are absolute game changers: vibration analysis and oil analysis. You can think of them as the stethoscope and the blood test for machines. Vibration analysis is pretty much exactly what it sounds like. Engineers stick these highly sensitive sensors on the gearbox to listen to its vibrations. See, every single rotating part in a machine creates its own unique vibrational signature, its own mechanical heartbeat. So, a healthy gearbox just hums along with this clean, predictable rhythm. But the moment you get a tiny crack in a gear tooth or a worn-out bearing, it completely disrupts that rhythm. It creates these weird spikes and abnormal patterns in the data. And by analyzing those frequencies, an engineer can figure out not just that there's a problem, but they can pinpoint exactly what and where the problem is. It's incredible. So, if vibration analysis is the stethoscope, then oil analysis is, without a doubt, the machine's blood test. That lubricant is circulating through every single critical part of the gearbox, and as it does, it picks up and carries all this evidence about the machine's internal condition. A lab can take just a tiny sample of this oil and learn a ton. They check its viscosity, is it too thick or too thin to do its job right? They look for contaminants like water or dirt. But here's the coolest part. They use special techniques to find and identify microscopic wear particles. So if they find tiny bits of bronze, for instance, that tells them a specific bearing is starting to fail. It gives you this unbelievably powerful snapshot of what's happening inside. Now, these techniques have been the gold standard in maintenance for decades, but right now, technology is taking us to a whole other level. We're moving beyond just preventing failure to accurately predicting it. And I want you to really think about that difference for a second. Prevention is about catching a problem that has already started. Prediction, that's about forecasting a failure before it even begins. It's the difference between finding a problem and telling the future, saying, this component has a 90% chance of failing in the next 30 days. And this massive leap is being powered by this perfect storm of technologies. You've got fleets of smart sensors connected through the Internet of Things, or IoT, that are constantly streaming data. Then, you have machine learning and AI algorithms that sift through this tidal wave of information, learning the unique health signature of every single machine. They can spot deviations so subtle a human would never ever see them, which allows for predictions with just astonishing accuracy. So here's the big takeaway. We are building a world where we can listen to our machines, understand their health in real time, and actually anticipate their needs before they even break. And that leaves us with a pretty fascinating question to think about. If we can give our critical machines a regular health checkup, what's stopping us from doing the exact same thing for our bridges, our power grids, and the health of our entire infrastructure?